So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as common structures of metamorphic rock. So in the previous lectures we have already discussed about igneous rocks and sedimentary rocks and their basic types and what are the main structures and how they are formed, what are the formation methods. So because all the rocks are formed through either the formation process of all the lava, cooling down of lava or magma. So here we are going to discuss about the metamorphic rocks. So as we know, we have already discussed in the previous lecture about the igneous rocks, which is formed basically from cooling down of lava or magma. So here metamorphic rock is a form where it is formed by it goes through a very much heat and pressure conditions of the previous parent rock like igneous or sedimentary rocks. Both the rocks can become as a metamorphic rock because it goes through a heat and pressure conditions. Now let us start this lecture today and we'll be discussing about the common structures, basically how they are formed and what type of structures they have. So let us start with first of all about the metamorphic rock. So as I said, metamorphic rocks form through a transformation process. So what is the transformation process of pre-existing rocks? What do you mean by pre-existing rock? Means already the rock which is formed, like you have a igneous rocks which is formed by the lava or magma when it cools down. So lava basically when it comes out of the volcano, it just cools down and it will form a rock. So that particular igneous rocks will be going through a very much pressure conditions and it transforms the transformation of pre-existing rocks due to heat, pressure and chemical processes. Now here you can see here pre-existing rocks means what? The pre-existing rocks means already either igneous rocks, okay, igneous or sedimentary or metamorphic also. Okay, so these are the three rocks basically, the types of rocks which are formed. So when you talk about the metamorphic rock, so it is formed by the previous existing rock. When already a rock in a igneous condition, already the rock in a sedimentary condition, or else already the rock is in metamorphic conditions. So these conditions, already the parent rock is available and it goes through the heat and pressure conditions with a chemical process. Then the new metamorphic rock is formed. So their structures and textures. Okay, basically the structure means the alignment of the rock and the proper fixing of the components or the particles. How basically the structure it looks like, and the texture. Texture means either the rock is in a smooth condition, smooth touch, or a rough touch of the rock, or something like a bubbles or something like a sandy kind of texture. These kind of textures are basically due to at the time of the formation process itself, it will change. So it depends on the intensity of metamorphism. Metamorphism means the transformation process of pre to new rocks. Okay, so this all depends on the metamorphism and mineral composition. So as we know in the previous lectures also we have discussed, like there is a lot of difference between a rock and a mineral. So when you talk about a rock, that means it can contain around 2 to 3 types of mineral in that particular rock. But once you talk about a mineral has a unique property. It has its own a single unique property itself. So when you talk about a rock here, so it may contain 2 to 3 kinds of mineral which can be present in the rock. Okay, so the structure and texture depends totally. First of all, it depends on the first thing is metamorphism. Second thing is about the mineral composition. So what type of mineral which is present in that, based on that the composition will be decided. Now metamorphic rocks are rocks that have been transformed from their original form, whether igneous, sedimentary, or older metamorphic. As I said before itself, in the first point, that the metamorphic rocks are formed from older original rocks. Already the original rocks are available in the form of igneous, sedimentary, or older metamorphic rock. So these three types of rock, again, they can form as metamorphic rock. Okay, so due to heat, pressure, and chemically active fluids within the earth crust, and this process is known as a metamorphism, right? So metamorphism is basically the whole process when a rock transforms through a older rock to a newer rock, right? Older rock, it can be a igneous rocks, can be a metamorphic rock. Okay, suppose there is a igneous rocks, so these rocks can be transformed as a metamorphic. Okay, now next you have a sedimentary rocks. This also can be transformed as a metamorphic. Okay, metamorphic. Now you have a metamorphic rock. Okay, so metamorphic also can be transformed as a metamorphic rock. Okay, so this, you can say, this is the new formation, and these three are already existing. Okay, already existing, as we are saying here. So the original form which is already existing, that can be converted to metamorphic rock at the time of a metamorphism. Okay, now when you talk about this, what are the agents? Basically, the transformation process is totally dependent on some kind of agents, right? So what are the agents of metamorphism here is, so first thing is heat. Heat is the main agent here for the metamorphism process, that increases mineral reaction rates, leads to recrystallization. Like it increases the mineral reaction, like whenever the heat is applied to a rock, it will change the properties or something, like it will react with the other type of minerals and leads to the recrystallization. Recrystallization means, so heat will make the material first of all molten. Okay, it will slowly melt the materials, and slowly when it cools down, it will be recrystallized. So at the time of recrystallization, the structure and the what you can say is the formation or the texture, it all depends on the type of the recrystallization is happening. Okay, so next thing is pressure. So pressure is the second agent. First agent is heat, the second agent is pressure. So pressure is like lithostatic, causes compaction, directed reduces violations, right? Now here we have a lithostatic, means a uniform kind of pressure applied to the rock. Okay, like uniform means continuous, at the same speed the pressure is applied on the rock, which can cause the compaction. So slowly the rock, the molten rock will be compacted, and the formation and the texture will be totally smoothly compacted, right? So based on this pressure, the uniform and the differential here is produces the foilation here is the foilation is foilated kind of rocks, means it will be having a band like structure. Okay, so it will show you in the rock, like at the time of the formation there will be a band like structure here. And chemically active fluids promote ion migration and new mineral growth here. And time is the one more factor here. Metamorphism is a slow geological process. Okay, so immediately if we think it will convert, it takes years and years, ages and ages to convert the original rock to a metamorphic rock. Okay, now when you see the types of metamorphism, what are the different types here? The types of metamorphism here is like contact metamorphism, regional metamorphism, dynamic metamorphism, or if you talk about the contact metamorphism, so occurs when rocks are heated. When rocks are heated by nearby magma, produces non-foilated rocks. An example like marble and quartzite. Marble is the most popular and what you can say is it is hugely used in the industry for the construction work. Most of the time we see for the construction of the sculptures or some kind of temples or flooring and all, this marble is very important where we use this in this kind of construction work. Quartzite is also the hugely used in the construction works. And second thing is regional metamorphism. So what is a regional metamorphism here is which acts over a large areas with a high pressure. So in some region they will be having areas with a high pressure plus temperature, and common in the mountainous region where you have this particular region will be having a high pressure as well as the high temperature. Common in the mountain building zones produces the foliated rock. So wherever there is a region where you can see the areas which is under the high pressure and the temperature, there the rock types of the metamorphic rock types will be in the form of foliated rocks. Okay, so example here we have slate, schist and gneiss. So these are also commonly, if you know, like slate is a very common what you can say kind of rock. Okay, kind of rock or metamorphic rock, which is used in the industries, right? For the flooring or roofing purpose, we use basically this kind of rocks. Dynamic metamorphism caused by the intense pressure along with the faults and produces the mylonite and cataclastic rocks. Now we have a common structures here. So we have common structures of metamorphic rocks. So what are the common structures basically when at the time of the formation we have here is, the first one is foliated structure. Foliated structure, then we have a slaty structure, then we have a cystose, and we have a gneissic structure. So these all kind of structures are basically formed at the time of the metamorphism. So what is a foliated structures? Let us see here. So it's a parallel alignment of mineral. Okay, parallel alignment of mineral due to directed pressure. So parallelly when the rock is like this, so parallelly the alignment of the mineral will be like this. Okay, it will go like this in the rocks. So slaty structure, very fine layers. As we know, the slaty type of material or a rock will be having very fine layers, breaks into thin sheets. So when you try to break the slate, it will break as a thin sheets, right? Cystose structure, medium to coarse grained with a visible mineral. So it has a medium to coarse grained with a visible mineral alignment. Like example, we have a schist here. Now we have a gneissic structure. So gneissic structure. So it is a alternating light and dark mineral bands. It has a kind of structure, and the example here is gneiss stone. Now, we have a difference if you see here. So this image will tell you about the foliated and non-foliated. So we have a basically majorly if we classify metamorphic rock, so that is classified as foliated or non-foliated. You can see here in the foliated kind of it has a band kind of structure here. Like you can see the bands here, like ribs. It will show on the rock. And non-foliated is a uniform kind of. It's a uniform kind. Okay, uniform kind of structure here. So when you talk about the non-foliated, lacks distinct layering, so it doesn't have any kind of layering here. So you can see in this. So it doesn't have any kind of layering. So there is no layers here in the non-foliated. Okay, and minerals grow in the equidimensional form. Examples: granoblastic structure. So uniform grains interlocking in a mosaic pattern, like we have a pattern like marble or quartzite. So it is a kind of uniform grains. Like you can see in this, the minerals here, the composition of this rock, it has a uniform structure. Everywhere it is evenly spread. At the time of the heat and pressure conditions, the uniform the spreading of these particles are uniformly spreaded and slowly it crystallizes in this particular form that we call it as non-foliated. So it lacks the distinct layering first of all. Second thing, minerals grow in the equidimension forms. Examples, we have a granoblastic structure, uniform grains interlocking in a mosaic pattern like marble and quartzite. So if you have seen a marble has a very fine layers. It has a very fine compacted type of rock, and it's very useful in the construction works. First of all, it is used as a flooring as well as making a idols or sculptures and all. So next we can see is hornfels structure. So there is one more type of structure in the non-foliate. Non-foliate is basically massive, we say, or uniform. Okay, massive kind of structure or uniform kind of structure. So extremely fine grains, hard and compact due to the contact metamorphism, like hornfels. Like hornfels are basically, it is extremely fine grain kind of structure, and it has a compact due to the contact metamorphism. Now you have a lineation structure. Lineation structure is what minerals aligned in a linear fashion. So in a linear lining fashion like this, you can see the minerals are aligned in that particular fashion in a planar way. We call it as lineated schist. Schist is a kind of rock. Schist is a kind of rock, metamorphic rock. When you see this kind of rock, you may see the linear fashion of this rock. Okay. Now you have a organ. Organ is a eye-shaped. You have a eye-shaped kind of structure like a large mineral grains for blast or something like a surrounded by a finer matrix resembling eyes. Example, organ and genesis. Now you have a myelonictic structure, strongly sheared and finely crushed, typical of high strain zones. For example, myelinite. So this, as I told you, foliated and non-foliated. As you know, non-foliated is a massive kind of structure. It's a uniform kind of structure. You cannot see any kind of layering like this. Okay, so there is no layers here, as well as the structure is a uniform, or we call it as massive. Massive kind of structure is non-foliated. So this kind of structure is you have a banding layers here. Okay, bands or layers on the rock. This all. So here, when you talk about the common structures here, so foliated texture, if you see, result from differential stress, slaty structure, fine grain splits into the sheets. Phyletic structure, slightly wavy, foliation with a silky sheen. Okay, and cystose texture is a coarse and it's a visible mineral with a scaly and flaky appearance. And genesic texture is alternating mineral bands of light and dark mineral. Example, genesis here. Non-foliated, as I told you here, formed by the recrystallization, and you have a crystalline texture of interlocking minerals grains, typical of marble and quartzite, and you have a porphyroblast texture, like large, well formed crystals in a finer ground masses. Example, the garnet. Garnet is one kind of example here, which we can use as a even the schist is one of more example of porphyroblast texture. And hornfels texture is extremely fine-grained, dense and hard due to the thermal metamorphism. So hornfels are the examples of the hornfels structure, which is a fine-grained kind of structure, and it has a dense and hard due to the thermal metamorphism process. Okay. So this was about the common structures of metamorphic rocks, which it is produced by the older rocks. Like already the present existing parent rock is present, and from that parent rock, the rock goes through the heat and pressure conditions, and finally it is converted as a metamorphic rock, where the metamorphic rock, the best example of metamorphic rock is marble or schist, or we call it as genesis, which is used in the construction industries, widely used in the construction industries. Okay. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.